Good afternoon and welcome. I'm Brent Donaldson, Senior Editor for Modern Machine Shop. Today's webinar, brought to you by Machine Metrics, will explore some of the top workflows that benefit manufacturers by creating automation on the factory floor, saving time, increasing productivity, and positively impacting capacity. The launch of Machine Metrics workflows is a remarkable step forward in enabling flexible actionability on this data. These workflows start with insights derived from machine monitoring data, which act as triggers to automatically fire off actions such as notifications, incidents, or webhooks. Please note that if you have questions at any time during this presentation, you can type them into the questions panel on your screen, and we will do our best to answer them at the end. Also note that this webinar is being recorded, and you will receive a link to that recording via email after it has finished. With that, I will turn it over to Justin.
Thanks very much. Good afternoon. My name's Justin Garland. I'm the sales manager with Machine Metrics. And today I have a team of experts from our company gathered here to talk to you about what you could do with machine data in terms of generating actions through automated workflows. First, I'm going to start by introducing the team. I've already introduced myself. We also have Jacob Lozier, our co-founder and CTO, Paul Richards, our software engineer, Cullen McCarty, our customer success engineer as well. Thanks for joining today, guys. So a couple of quick housekeeping notes. First, we're going to give you an introduction to Machine Metrics, kind of walk through the agenda here. We'll talk about why workflows are important, what the impact they can have on your business. And then we'll talk about some of the top workflows that our customers are currently using and how they're leveraging them to drive actionability on the shop floor. And then we'll finish up with some Q&A at the end and address any questions that you guys might have. As we mentioned before, we'll have that chat box open if you guys want to throw any in there. Some other housekeeping items. Just know that this webinar is being recorded. So if you can't catch the whole thing, no worries at all. We'll send you a link after the webinar. And of course, as always, we encourage interaction. If you guys have questions, please don't hesitate. So we'll start with a little bit about us. And for that, I'm actually going to go ahead and launch a video for you, give you a little introduction for Machine Metrics.
Manufacturing produces more data than any other major industry in the world, yet has been slow to adopt the digital mindset transforming industries like agriculture, banking, and healthcare. Manual data collection is time-consuming and inaccurate. Operating on gut instinct alone leads to inefficiencies and poor decision-making that affect every component of a company's operation, from significant downtime to production losses. We're in the age of Industry 4.0, and manufacturers need every edge they can get to stay competitive. Real-time actionable data is that edge. Your machines generate hundreds of data points every millisecond, all of which tell a story of what happened in the past, what's happening now, and what will happen next. It's time you harnessed that data and jump-started your factory's digital transformation. Machine Metrics provides an intuitive, flexible monitoring platform that easily collects data from any piece of manufacturing equipment and transforms it into powerful, actionable insights. Why does Machine Metrics succeed where so many others have failed? The key is in our ease of use and time to value. The Machine Metrics IoT platform is easy to install and implement. You'll start visualizing data in a matter of hours. Plug-and-play edge connectivity harnesses and standardizes machine data across your entire fleet. Our intuitive, out-of-the-box apps are easy to use and drive rapid improvements in efficiency. Training is minimal. Real-time shop floor dashboards, machine production and condition monitoring, historical reporting, and automated alerts instantly enable visibility and analytics to help your team understand the big picture. Build your own apps or seamlessly connect with your current shop floor systems to easily integrate machine data across your digital factory. Machine Metrics will help your team deliver the right information to the right person at the right time. Identify potential bottlenecks before they occur. Update cycle time standards in real time to improve pricing and scheduling. Detect anomalies and predict maintenance events before they cause downtime. Empower your workforce with step-by-step instructions to optimize processes. Enable lights-out manufacturing with remote monitoring and alarm notifications. With Machine Metrics, any manufacturer can start leveraging their machine data immediately to drive improvements and provide the foundation for scaling data across their operations. It's time to start transforming your factory, all with the click of a button. Harness the power of machine data so it can become your competitive advantage.
Great. So with that, we'll kind of dive into a little bit more detail what Machine Metrics is all about. And for that, I'm going to just open up my screen here, run through a couple of slides. So as you saw in the video, it's never been more important to deliver the best product faster than ever. Continuous improvement in manufacturing starts with capturing insights from your operations, specifically your machine assets and your people. Machine Metrics Industrial IoT platform has automated machine data collection and production analytics to deliver data-driven insights in a matter of minutes. Jumpstart your digital factory and take action that improves your bottom line. Manufacturing today is consumed by manual processes that lead to inefficiencies. This is evident in Machine Metrics benchmarking report that states the average machine utilization rate is less than 30%. So is industrial IoT and Industry 4.0 the silver bullet? The reality is that most IoT implementations fail. 81% according to a McKinsey study conducted just last year. The reasons for that? High failure rate, it's due to the complexities of connecting such diverse equipment, often with years of custom development and integration required before even obtaining any initial value. So for the digital factory to reach scale, we know that the process has to be easier. Automated manufacturing equipment and the skilled people who operate make up the beating heart of any manufacturing operation and represent the largest capital expenditures. These machines are worth hundreds of thousands, if not millions of dollars, and produce more data than any other industry. Yet that data is not being captured or analyzed to improve efficiency despite all of those innovations that we mentioned. So that's why we built Machine Metrics. We're the manufacturing's first industrial IoT platform for machines. Make it very easy to capture and transform data and make that data actionable through increased visibility, predictive analytics, and configurable workflows, which we'll get into here in just a minute. The whole key here is to automate that manufacturing process around the machine. Our team is based out of Massachusetts. They came together in 2015 to transform manufacturing. Over the past 6 years, we've connected to thousands of machines across hundreds of different customers worldwide. Customers in discrete manufacturing industries that reach as far as medical, automotive, aerospace, oil and gas, and industrial components. We also touch heavy industries and much more. So we've worked with everyone from small mom and pop shops to large OEMs. And as the machine data component of the digital factory, Machine Metrics is powering that manufacturing digital thread. We're connecting to other best-of-breed factory systems, providing real-time data throughout the entire product lifecycle. And that's what we call the operating system for the autonomous factory. We're really just getting started with that, and you'll see some examples here today. Once you're able to harness the machine digital thread, your opportunities for automation are really endless. Our launch of Machine Metrics workflows is a remarkable step forward in enabling flexible actionability on this machine data. Now, Jacob will explain what this progress represents, and then we'll explore some of the top workflows that are benefiting manufacturing today. Jacob?
Thanks so much, Justin. So what are workflows and why are they important? With manufacturing systems, there are a number of different software products that you'd use to tie together and manual processes that you tie together to build your business. And while Machine Metrics can get the data from equipment, we aren't going to build an ERP. We aren't going to build a CMMS solution, but you need to connect them. And the source of truth, the one thing that doesn't lie is machine data. Operators can accidentally input incorrect information into a system, but the machine data always tells the truth. So what we set out to do is build a system that allows for that machine data to drive many of the systems within a factory. We automate the data transfer and allow for low-code applications to be built so that you capture the knowledge of your business into the cloud, into the system that's connecting all those pieces, so that the best people, the right people, are getting the information that they need at exactly the right time, or the process that drives different connections between different applications is fully automated and solves the problems of your business.
So now you have an understanding of why machine metrics workflows matter. We'll go through a couple of ways our clients are leveraging the built-in application to create automation on the factory floor. We'll provide examples of how workflows are used to save time, increase productivity, and positively impact capacity. Now we're going to start by addressing one of the biggest challenges that still plagues the manufacturing world today. Even in this time of hyperconnectivity, it's breakdown in communication. In many manufacturing environments, it can be difficult for production staff to meet expectations when things are going well, let alone throw a few curveballs at them, some unforeseen disruptions, and performance expectations need to be recalibrated. If the system for response communication is not effective, then they cannot truly take ownership of performance. Machine metrics workflows provide an extremely simple and user-friendly communication system that gives the operator a voice when they request a call for help and immediately notifies designated personnel of what action is required. Knowing is half the battle, right? So you can use various methods of notifications like alerts, you have dashboards, all to drive action. Communication rules can be established so you can escalate levels to management if the issue becomes critical or the disruption is prolonged and continues to impact performance. From what you might learn tracking downtime trends with machine metrics, you may decide to implement continuous improvement workflows targeted to streamline operations. This tool makes it extremely easy to implement those new process workflows. So what I'll do now is I'll get into an example of how that might be done.
Hi everyone. Everyone see my screen okay here? I'm Paul and I'm an engineer here at Machine Metrics, and today I'll be showing you all a demo of one of our workflow actions, a webhook, and how we can use that to automatically communicate with external systems. In this case, a computerized maintenance management service called Fix. So we're here in our main application. We're on our workflows page, and we're going to go ahead and set up a new workflow. So here in our form, we'll give it a name. We'll select the machine that we want this workflow to monitor. So for this one, we're going to monitor our tea kettle machine. And we'll select the trigger that we want to activate this workflow. In this case, it's going to be downtime categorized. And for our reason, we'll say planned maintenance. And from here, we'll go ahead and add an action. Our action is going to be a webhook. And we have a few options here that we can select when we set up our webhook. We first have a delay. This is going to be relevant to our trigger here. With our downtime categorized, we could delay whether or not we want to send off this action, or if it's been resolved, not send it off. But we want no delay here. We'll set 0. We'll have our URL here, which is going to be a consumer for our webhook. So this is generally going to be a low-code application that's going to do a couple of things. In our case, too, it's going to just verify the sender as Machine Metrics, and then pass on some relevant information, in this case, to Fix, the CMMS, via their API. So we'll enter the URL for our consumer here. And then our secret is another tool that we're using here to verify Machine Metrics as the sender. So this is specific to this particular webhook. It'll be used to generate a Machine Metrics signature, which our consumer will then verify, yes, this is coming from Machine Metrics. Go ahead and do whatever we need to do with our data. So I'll go ahead and add our secret here. And we'll create our workflow. And from here, we'll jump next into our operator dashboard. So this would be on display at a tablet at one of our machines. So this would be sitting here next to our tea kettle. Not a whole lot going on this machine. It's just a tea kettle. It's got two states. It's either boiling water or it's not. In this case, we are idle. We're not boiling water. So in order to trigger our workflow that we just set up, we need to categorize our downtime as planned maintenance. We can see we have one here, but I'll create a new one by splitting this one, effectively terminating this downtime and creating a new one. So let's go ahead and do that. We will say that our tea kettle is down now as planned maintenance. We're not making tea. Our downtime has been categorized. And we'll jump in here. And we can see we just triggered our new work order. So this was generated as we categorized the downtime on our machine. It grabbed some contextual data about that downtime, the machine, when it was triggered, all that good stuff, and it sent it on to fix for us automatically. So now it looks like we sent our CEO Bill here an email, so he knows that our tea kettle needs some maintenance, and appropriate action can be taken to make sure everything gets back in order. I'll toss that back over to you, Justin. Thank you.
Thanks very much, Paul. What we'll do now is we'll show an example of how that can be done on the quality side. So we can implement a workflow around first article inspection on the quality side to do sort of the same type of thing. So what we can do is name the workflow first article inspection and designate a trigger for when the job enters a setup stage. Now, when the operator goes to start that job, it'll launch the setup stage and we'll see first article inspection. And as Paul had pointed out before, we can designate a user account to be notified after either a certain amount of time, or we can even generate an incident report and prioritize that assignment to an individual as well. Once that setup stage is entered, that process is generated automatically, and that person will have an email in their inbox or a text message on their phone, and then they'll be able to take action as soon as it's needed down at the machine. So for now, we'll get back to some other interesting aspects of data flows. I think we're going over to our buddy Cullen, who's going to talk through some of that stuff as well. Cullen?
Yeah, thanks, Justin. So I'm going to go ahead and share my screen as well. Okay, and so yeah, I'm going to be showing a few of the really easy applications that you can sort of use these workflows with. And these are completely no code. That's what's fun. You can really hit the ground running with these very easily to tie in your other systems. So for this example, I'm going to be doing two. I'm going to be doing one with Google Sheets and another with Microsoft Teams. Google Sheets, let's pretend that we had a sheet that we had a sort of report on that we wanted to continuously update, but we were tired of maybe running queries to populate it with new data all the time. We just wanted this report to be up to date all the time. And why not? So we've already seen how to create a workflow. So I'm just going to jump right into actually triggering this. So let's go over here and we can see my Google Sheet here. And hey, look at that. We can see the latest tea kettle plant maintenance that just came in. We're going to go ahead and categorize another. So I'll jump over to my lathe. I'm going to split this downtime just like Paul did. And I'm going to say unplanned maintenance. Submit that. And there it is, just like that. Now I have a sheet that you could add a bunch more data to this, but either way, it's just going to automatically keep populating without you having to do anything. Just the regular process of categorizing downtime from your machines. As that goes on, your report will just automatically have new data in it. But then we can also do some other really interesting things, and we can connect to so many different applications. Because of tools, for example, I'm doing this with Zapier, which is just an automation tool. Doesn't require any coding experience to use. Anyone can use it. It's great for just automation. And it connects to hundreds of different applications, which we can connect to. So it only takes a few minutes to set up. So for example, let's say Teams is something maybe you use. Here's our Teams environment. It's a little empty. Yours is going to be a little bit more populated. We're just doing a demo here. So I'm going to jump back and say, maybe just like Justin was saying on the first article inspection, maybe I want to notify my team whenever a machine is ready for that inspection. I'm going to split the downtime. Say first piece inspection here. Submit that. Oh, you can see there's a notification here. All right, I've got an alert. And I come over here. You can see right here, I have a new alert that just came in. So just like that, my team, in whatever platform you choose to communicate with, would just have received a message. It only took a second or two. So these ways, you're not having to do anything extra or even work outside the platforms maybe you're already using. This data can come to you. And so that's just 2 examples. There's a whole lot more, but I'm going to go ahead and throw it back to the rest of the guys here to dive into the rest of it.
Awesome. Thanks, Colin. Now, Jacob's going to jump into some of our tools around predictive maintenance and tooling optimization. Jacob, go ahead.
Sure thing. Would you mind sharing those slides again?
No problem.
While he's getting that up, Machine Metrics is really doing something quite unique here with our predictive analytics. A lot of our workflows that we've talked about so far are around data that we've captured from machines for the last 6 years, and also from operators and from other pieces of software. And we're able to connect all that. What we're talking about for predictive analytics, though, is something much different than that. It's much bigger than that, very powerful. Not to say that what we talked about so far today is not powerful. But what we're doing here is we're capturing data from certain types of equipment at 1 kilohertz rate. So a very high frequency from many different data points on a machine. And there's a number of examples that we can look at. 2 that we'll highlight here. One is tool optimization and the other is quality optimization. But by capturing data at such a high frequency, we're able to pull apart that signal, whether it's vibration or spindle speed or temperature is fine at a much lower frequency. But these things like vibration, we're able to pull those apart and actually understand what portion of that signal represents the friction applied by the spindle versus what friction is being applied by the cutting load, actually cutting the material. And so we're able to dissect that signal and get some really amazing insights. You can see here on the right, this is a number of cycles that we've captured data for on a particular machine making a certain part. And you can see on that graph, going from left to right, top to bottom, that signal starts off to be very consistent. Then all of a sudden, something looks a little different. And while that part might have actually come out fine, it's a signal that something is going to fail much more drastically and can be very costly. In this case, it's a tool failure, but there are cascading tool failures that can result from this. And what we've developed is a way to detect these failures before they occur, or at least when there's these predictive indicators of a much more drastic failure, and stop the machine before that drastic failure, saving a significant amount of money or downtime. And there's other use cases. Maybe you don't want to stop the machine. Maybe there's a significant lead up to a particular type of failure, a bearing failure or something along those lines. We can detect those and send out notifications using our webhooks even to start to notify other departments or even reach out to your service provider. So there's a lot of use cases that can come about through these webhooks and this particular technology around high frequency data. Let's go to the next one around quality optimization. So that previous one was about a tool failing. This is simply with a tool that might actually just be compromised in some way, not completely failing, not breaking or crashing, but just maybe having a chip on it or becoming dull to the point where parts just aren't coming out to spec. And you can see the same exact observation here. We're able to easily identify when something goes out of spec and either halt the machine or alert the appropriate person so that QA can know ahead of time that certain parts are going to be out of spec and maybe they have to provide a little more attention in that area. So the work that we're doing around predictive analytics and high frequency data capture is really groundbreaking in the industry and providing some really remarkable cost saving results for our customers. So thank you, Justin.
Awesome. Thank you, Jacob. So I think now we'll shift over to our Q&A. And for that, I think we'll go to our moderator.
Great. Sounds good. Thank you, everyone. So to our live audience, this is just a reminder that right now is your opportunity to ask questions of the panel. Please type them into the questions panel and we will do our best to answer them. In the meantime, it looks like we do have a few questions in the queue. Let's start here. How does Machine Metrics collect data from machine tools, and can you connect to other types of manufacturing equipment?
Yeah, so we use a variety of different methods to acquire data from different machine tools. In some cases, where you may have a legacy piece of equipment or more of a manual machine that doesn't have a sophisticated control, we could start by monitoring through signals that might come from a relay or some type of I/O signal. A lot of times we'll deploy a current transducer to measure amperage on a motor, but we can still find ways to give insights around the productivity performance of that equipment and still be able to gather insights in terms of downtime and even drive workflows. Now, the most sophisticated and the simplest plug and play type of integration will, of course, be on the more modern controls, where we can automatically map the data points on that control just by plugging the machine into our edge device. So we have a variety of flexible options depending on your requirements, and we have a team that works with us to scope out what that type of integration would look like.
So we have two questions that are, I think, I read them as being a little bit related here, and I'll try and combine them. We have a couple of audience members who want to know a little bit more detail on the computer hardware and connectivity hardware. Is this hardware supplied by Machine Metrics? The input devices needed, is this pulling from MT Connect, or is it capturing electrical signals?
So we could do both, actually. We can pull data through an MT Connect type of communication protocol. We can also leverage FANUC Focus, OPC UA, pretty much any type of COM protocol that's out there. But we can also supplement if, let's say, the control doesn't give the user enough diagnostic insights about the environmental conditions around that machine. We could supplement that data through another data collection method, and we can still standardize that data structure and serve it up all through a single interface. So in some cases, we may leverage like an electrical signal, but in many cases, it is data coming straight off the machine control. In terms of hardware, so for the I/O side of things, again, we may use sensors, we may use current transducers tied in with an I/O module. Machine Metrics does supply a particular range of I/O modules, but you're not limited to that. So we can talk to other, best of breed I/O modules that are out there. And then, of course, those devices would be connected directly to our edge device, which would reside on the machine network and then tied to the AWS cloud. So it's really two main pieces of hardware that come from Machine Metrics, and then integrating either directly with the machine control or through that I/O module with additional sensors. I think that answered all of those questions.
I think so. Okay. The next question is pretty straightforward. How many machines can Machine Metrics connect at one time?
Ooh, that's a good question. I don't know if we've ever been
I can take
challenged.
That.
Yeah.
No, I can definitely take that one. So right now, we are connected to thousands of pieces of manufacturing equipment around the globe. And so where the limitations start to fall in is really just how many machines can you connect to a single edge device. And the recommendation around that is about 50, but we've seen customers push the bounds of that to about 100. There is no limitation as to how many edge devices you can have within a company, within an organization. So really there's no limit as to how much other than maybe your own internal network bandwidth that might limit that. There's really nothing that our platform is scalable and that we can just continuously grow out and add more capacity on our side to support any needs that you might have.
Excellent. Next question. What is the difference between MES and machine metrics? Can someone use both?
Yes, absolutely. So machine metrics is really designed to work with the best of breed applications that you're already using and drive those and improve process with machine data. So MES solutions, while they are what you're using today, it might be the case that with a product like machine metrics and automating the data capture, you find that an MES is not actually the right thing for you. But we can work right alongside it as you start to go down that path of your digital transformation.
Very good. Next question. Somebody in the audience is currently doing a demo with a competitor, and I have to name it this competitor because otherwise you won't know what the rest of the question means. Competitor is Amper. Do you offer a similar program? What is the cost structure by device? Is it monthly, etc.? I'm just reading the question as it exists.
Yeah, so compared to a solution like Amper, machine metrics offers definitely extensibility above and beyond that, and as well being able to capture data, on the diagnostic side, of course, with our high frequency capability, especially at a much higher fidelity rate. In terms of a platform, I think we have many more areas to extend data to, and also with our automated workflows that you saw today, we go way above and beyond just being a machine monitoring solution. And in terms of our cost structure, we are a SaaS platform. And so we typically set up a contract on an annual basis. And if you'd like to see what cost looks like on your machine set, what you could do is get in touch with a machine metrics sales representative, and they can walk you through what pricing looks like for your manufacturing plant.
Very good. Next question. How does machine metrics interface with ERP systems, and which systems do you work well with?
Jacob, you want to take that one?
Can you ask that one more time? Apologies.
Yep, sure. How does machine metrics interface with ERP systems, and which systems do you work well with?
Got it. Yeah, so we absolutely do. One of the ways that you can connect machine metrics to an ERP in the most basic sense, if you really just want to scratch the surface, is by importing jobs into our system. But you'll quickly have opportunities to go well above and beyond that by integrating using the workflows that we talked about today, showing how when an operator starts a machine in their ERP, you can connect that to machine metrics with open and extensible APIs that allows your ERP to drive machine metrics, and use our workflows to go in the other direction, have machine metrics drive your ERP so your data is much more reliable and consistent. Some examples of some ERPs, and the list is long, but some examples are things like Epicor, JobBoss, and really anything that has a public API, we can connect to and drive. One quick point, going back to Amper. Amper, from what our research has shown, is mostly about machine utilization, but with the richness of data that we get from the machine control, we can provide a significantly more accurate product and much broader data set, including parts. I mean, Amper, when you're talking about just machine utilization, you lose how many parts were made in a given window, so you have no opportunity to understand the performance of your product. And when you're talking about the performance of your operation, when you're talking about OEE, that's a critical component to understand the efficacy of your operations.
Very good. Next question. Does the edge connection connect directly to machine metrics, or is the controlling software located on site?
Does the edge connection connect directly? Can you repeat that one more time?
It's in the
absolutely. Does the
sorry? Oh, the edge.
Does the edge connection connect directly to machine metrics, or is the controlling software located on site?
Okay, so there's really two main components when you talk about software and edge connection and machine metrics. We do have our proprietary software that does live on the edge device, and that's what enables us to have that automatic mapping of data points on your machines. But we do host software within the AWS cloud as well that does perform a majority of the analytics. So we have some technology on site, but majority of it being in the cloud.
Very good. Next question. Is Machine Metrics easy to install, and do we need to pay someone to install it for us?
Yeah, so the majority of Machine Metrics customers actually do install the industrial IoT platform on their own, and the reason why is because it's a very streamlined process. We make it easy for our customers, and of course, with that, you have a great reduction in the cost in order to obtain value. So rolling out the technology, scaling it throughout your organization is a really easy thing to do. But we do recognize that constraints around resources, especially nowadays, can be difficult. So we do have a team of integrators. We can quote on-site integration if that's something that you require.
So I wanted to ask, this is for anyone on the panel. This is just coming from the perspective of a writer for Modern Machine Shop, and I've written quite a bit lately about machine tool dynamics and some work that's going on at Oak Ridge National Laboratory around what's alternately called tap testing or again, machine tool dynamics. And I heard part of the presentation reference that you guys can capture data that seems to align with some of that work, but I want to make sure I'm getting that right. There was a section where you guys were showing some frequency ranges, and I want to clarify, is that data something that you guys can capture? Ultimately, what I'm talking about is sort of finding the sweet spots that can be hard to detect for frequency ranges that cause chatter and deflection.
Yes. So one thing I didn't mention, which is actually a really important point, is the approach that we're taking here is by working with machine tool vendors and controls that have this data available through APIs. And this isn't a point that we need to make lightly. This is actually really important. It makes the installation process a switch. There's no hardware installation. You don't have to rip apart your machine and add sensors and get those sensor locations exactly right. We're able to capture this information directly from the control at a kilohertz rate, and yes, detect jitter and chatter, and understand when certain very minuscule anomalies are occurring in the machining process, and use that as a predictive indicator towards failure. We can detect that in very short time windows, but also over long ranges as well.
Wow. I mean, that's huge. Like the work that I'm referencing that is going on at Oak Ridge. I mean, using that kind of feedback, you can find these very narrow windows that really impact your overall throughput. And this is news to me that you guys are kind of working in this direction. That's fantastic. I think that does it for our questions today. And with that, I want to thank Machine Metrics and this excellent panel for making this webinar possible. And thank you to everyone for listening in. You should receive an email with a link to the recording soon. That concludes today's presentation. And I want to make sure that I'm not cutting things off too quickly.
Yeah, we did want to mention
else that you guys have?
Yep. Yeah. I wanted to mention an upcoming webinar on our new operator dash. Our version 2.0. It's going to be held on Tuesday, April 13th at 2 o'clock. So you can register now at machinemetrics.com/events, and you can learn about how we're implementing our technology at the operator level, and how our customers are using that to drive action on the shop floor, specifically at the machine side. So thanks very much, everyone, for joining today. We appreciate your time.
Great. And that does it. That concludes today's presentation. On behalf of Modern Machine Shop, I'm Brent Donaldson. Thank you for your time and enjoy the rest of your day.